worm and worm wheel. Left hand side, you can see, you know, there is the gear arrangement. So this type of gear arrangement we call worm and worm wheel. Okay, so why we call worm? Because you know this upper the gear, it's look like a worm, no? You know the worm, there's a one creature, so that's the same shape. That's why we call the worm. Okay, worm and worm wheel. Wheel is the below part. Below part we normally call wheel, and upper part we call what? Worm. Okay, so this is the that's why we call this specific type of gear we call worm drive. Okay, worm drive. Okay, let's start. Okay, what do you mean by this worm and worm wheel? Okay, as I mentioned on the introduction part, you see this one is the worm and this one is the worm wheel. Okay, so why we are interested in this mechanism? Okay, so this mechanism normally transfer the force and motion between two perpendicular shafts. You know, for example, this motor shaft on this plan, right? But this wheel shaft on this, you see, okay, this worm shaft on this plan and this wheel shaft on other plan, okay, in a perpendicular direction. So for this kind of the application, we use this worm and worm wheel. Okay, you may ask some question, why the bevel gear? That means the transfer the perpendicular forces and the motion between the perpendicular plan. So this is also similar one, but this one have some special advantage over bevel gear drive. Okay, that's why we are interested in this type of the worm drive also. Bevel gear also is transfer the motion and transfer the forces between the two perpendicular plan. But this is also similar concept, but there's some special advantage over the bevel gear drive. That's why we are using this worm wheel drive. Clear? So normally how we define the speed ratio of this worm gear is determined by how many teeth on the wheel, okay, how many teeth on the wheel and the number of the threads starts on the worm. Okay, I introduced the new terms here, you know, the starts, number of the not teeth here. We are not talking about the teeth on the worm. We are talking about the starts, thread starts. Okay, I will explain what does it mean by these thread starts. Okay, because this worm gear drive, we use this special term starts instead of wheel, instead of teeth. Okay, normally wheel we call teeth, number of teeth, 1, 2, 3, 4, 5. How many teeth on this wheel? We calculate the number of the teeth is the total number of the teeth on the worm wheel. But when it comes to worm, we don't talk about the teeth. We introduce the term called starts. Okay, so we will. I will explain more about the starts upcoming slides. Okay, then you know the why major advantage over the bevel gear drive is the worm wheel drive. It's never the opposite way. It cannot perform. It's only perform in a one direction. Okay, so it can be the self-locking mechanism, no? It can prevent the reverse motion. So that is the special features that's that causes in the worm drive, okay, over the bevel gear drive, okay, because it can only allow in a one direction motion. If you turn it other direction, it can be locked or jammed. It cannot move. It's self-locked itself. Understand? So this is the special features the worm and worm wheel gear drive have. Large reduction can be achieved in a small spaces. I will explain how this worm and worm wheel can um, increase the higher gear ratio or very low ratio, either way. Okay, very low or very high gear ratio. So we can achieve through this worm and worm wheel, compare with the bevel gear drive. Okay, that's why we are interested in this worm and worm wheel. And also, you know, the only drawback associated with this worm drive is this significant performance lost by generate large loss of energy. You know, when you move, when you mesh between the worm and worm wheel, there is a heat will generate. Okay, there's a lot of wear and tear. So we have to lubricate this system more frequently than other gears, because this worm gear drive generate more energy. Okay, that is the one of the drawbacks associated with this worm gear drive. Okay, because bevel gear also is a similar kind of application we use, but this worm gear drive have some special features. That's why we are interested in this special gear arrangement. You know, this is how it's working. Normally the motor is connected with this worm. Okay, so when it rotate, okay, when it rotate the worm, this worm will rotate. You know, this is how the operation of the worm and worm gear. This is worm, and this one is the wheel or gear. Worm gear and worm. We introduced a new term, that is starts. Okay, we are not talking about the teeth on a worm. We introduced a special name called starts. Okay, so we can see what do you mean by starts. Okay, normally the number of the teeth of the worm is referred to as the number of the starts. But the problem is the how we define the teeth is quite different. It's not same as a you know, spar gears or helical gears, but it's quite similar. But the manufacturing method is quite you know, the nomenclature is quite different. That's why we introduced the term starts. Okay, the starts. Okay, but basically, what do you mean by the starts of the worm? Starts of the worm mean the number of the teeth of the worm. Okay, but how we define that teeth is quite different. For example, there are many type of the start worms. For example, single start worm and double start worm. Okay, so we can see normally if we are talking about the single start worm, you can consider the gear with the one tooth. Okay, the gear with the one tooth. So that's why we call the single start worm. So single start worm means one tooth. How one tooth gear converted into what? One single. That means single start worm. This one is, you see, we increase the angle, right? When you increase the angle, you see one tooth here, but when you increase the helical angle, you see how we'll obtain. We obtain the single worm, single start worm. Okay, this is how we get single start worm. Okay, one tooth gear, and we increase the helical angle until it became a single start tooth. Basically, it coming from the one tooth gear. Okay, basically it comes from one tooth gear. That's why we call special name called what? One single start worm. Clear? Let's go to the, now we are going to see double. That means two starts worm. Okay, okay, two starts worm. It's basically come from what? Two teeth of the gear. This video will show you how. You see, there's a two, you see the two teeth, then you see the helical angle increase. Two starts worm. Now you understand, you know, why we call single start worm and two start worm, three start worm, four start worm, a multiple start worm. Understand? Clear? So this is why we call the special name for the worm is a single start worm or double start worm. It means the base gear have a one, two, or three. Okay, that's why we call single start worm or double start worm or multiple start worm. Okay, as I mentioned, you know, the special advantage of the worm gear drive, normally the gear ratio of a worm gear is given by number of the teeth on the worm wheel divided by number of the teeth on worm, right? So in this case, let's take the single start worm. Okay, let's take a single start worm. Then in a single start worm, how many teeth? One. So one over number of the teeth on the worm wheel. How many? Maybe let's say this spar gear have 50 teeth. Then what is the gear ratio of this worm drive? 50 over 1. So the gear ratio is a 5, right? So you can get the higher gear ratio. Understand? So that is the special advantage of this worm drive. Even though even though it has some difficulty to manufacture, you know, it costs a lot compared with the bevel gears manufacturing, but it has some special character. That's why we are still interested in this special type of the worm drive. Why? Because its gear ratio is so high. Because the number of the teeth on the worm may be 1 or 2. But the number of the teeth on the worm wheel, 50 of 60. So it can give you the big gear ratio. That is the special advantage of this worm drive. Okay. Okay. So when we are talking about the worm drive, we are interested in the types of the worm drive also. You know, when we look at the bevel drive also, we look at the different types of the bevel gear, right? So likewise, you know, worm drives also have some major two types of the worm drives. One is a cylindrical worms, another one is a globoid worms. Okay, why we call the cylindrical? Because this worm is a cylindrical shape. You see, cylindrical worm. But another type of the worm, that's globoid worms. Why we call globoid? Because you see here is a straight line, right? You see this one is a straight line. Then this one is a straight line, right? This one is straight line. But for a globoid worm, you know, it has some parabolic like this. The worm has some parabolic profile. So that's why we call the globoid worms and cylindrical worms. But the globoid worm can hold more thrust, more load than the cylindrical worm. But it's difficult to manufacture. Okay, that is a drawback of the globoid worm. But globoid worm is a robust compared with the cylindrical worm. Clear? There's a major two types of the worm drive. Okay, now we come to the application of the worm drive. Why we are interested in this one? Have you ever gone to a dam area? If you go there, you can notice these worm drives. Okay, you can notice this worm drive. The major application, the worm drive is the gate, the sluice gate. You know the sluice gate, this one sluice gate. These kind of the gate, they normally use these worm drives because it can higher, higher gear ratio. So even the motors running very fast, the gate will open slowly, right? This worm drive is used in a crane, the crane and other kind of even the automobile also they use. For a steering drive also, some automobiles and vehicles use these worm drives. Now we are going to look at the forces acting upon the worm drive. Okay, this is the worm. You see, this is the worm, and this one is the wheel. So normally the forces, on the wheel, there is a axial force, Fx2, and radial force Fr2, and tangent force Ft2. These three forces, one, two, three forces acting upon wheel. Okay, then as per the Newton third laws, if there is a force when it's contact, there is always the reaction for the forces, right? So the cylindrical force, on the worm, we have the same equal but opposite direction forces, right? The axial force, the radial force, and axial force, and tangential force. These three on the worm. These three on the wheel. Okay, so these are the forces acting upon the worm drive. For a worm drive, the velocity ratio is given by number of the teeth on the worm wheel divided by number of the teeth on worm. Okay, this is the velocity ratio for a worm drive. Law of the machine is given by Fe, force. Okay, effort equal to A load plus B. So A and B are constant. So we are going to draw some graph like what we did for the previous practical, and we will find out what is the law of the machine for this worm drive. So why we need the law of the machine? Say, okay. So normally we use the worm drive. I said the major application of the worm and wheel is sluice gate. Okay, sluice gate. Why? Because we must know how much we need to open. Okay, how much we need to open. Okay, let's say in order to open a certain distance, how much we have to run the worm. Okay, we supposed to know, no? Otherwise the more water come into and sometimes it destroy your fields. Let's say this water all go to the fields, okay, like a paddy fields or something. So if you can't control the gate opening, then there will be the more water pass through the fields and can destroy your fields, right? So you must be very careful about how much the gate must open. So in order to open that much, how much the gear drive, how much drive, how much the speed it should be rotate. Everything you have to find out from the law of the machine, right? If you know the, in order to find out the effort, you can, let's take your law of the machine like this, okay? Then this one is the load, this one is the effort, okay? Let's say you have to give this much of the load in order to take in the water, okay? Based on your requirement of the water, you calculate the gate should open at this load. Okay, so you can calculate from the load of the machine how much effort you need to give. Okay, that's mean how much the motor will rotate or something. Okay, so that's why we whatever the mechanism we have looked at, we are interested in the law of the machine. This is our apparatus. Okay, this is our apparatus. Okay, now what you are seeing is what our worm and worm wheel apparatus. Okay, this is our apparatus. So using this apparatus we are going to do our practical today. Okay, so first of all I am going to explain all the main parts of this apparatus. Okay, let's get started. Okay, so this one, okay, this one is called worm. Okay, this one is a worm and this one is the worm wheel. You know, this one is a worm wheel, this one is the worm. Okay, this one is what? Load drum. Okay, this pulley is called what? Load drum. Okay, this pulley is called what? This pulley is the effort pulley. Okay, this one is the effort pulley, this pulley is called load drum. Okay, this one also pulley, but we call the special name, that is load drum. Okay, so this is the frame, the chassis. You know, this one is a chassis, these two are side bracket. Okay, or here you see there is a logo badge and this one is the label. Okay, so here you see there's a two hanger also. Okay, both side, one side is the load side, another one is the effort side. There is a two hanger as well. Okay, so these are the main components of our practical. Here they put, you know, why one start. That's mean this wheel, they say one starts. Okay, what do you mean by one start? When you put the one start, only one wheel in contact. One start worm mean, one start worm and wheel mean at the time only one teeth are missed. You see the one starts worm mean at the time only one tooth is missed with the wheel. That's why it's a one starts worm. You notice the fully in engage. Understand that? Fully engaged with the worm. That's why we call one starts worm drive. But if the two starts worm drive mean what? Two teeth in contact. There's a two teeth in contact. You know, it's look like a same. No, whether the single starts worm or double starts worm, it's look like a same, no? It's look like a same apparently, but you know there's a difference in operation. For a single starts worm, you know, the top one, only one in contact at a time. But for a double starts worm, the two teeth in contact at the time. Now you understand clear? So multiple starts worm mean what? Multiple teeth in contact. Clear? But normally we use, normally there's a one starts is a more popular in general. Okay? There are some cases two starts, but multiple starts is very rare in application. Okay, now we are going to do our practical. Okay, what we are going to do is we are going to add weight on the load side, on the wheel side, and we are going to add gradually on the effort side. That means on the worm side. Okay, to see what is the minimum load or minimum effort is required to lift or to move the load on the wheel side. Okay, so we are going to look at that one. What is the first steps we have to do in the procedure part? Okay, what they said, wind the cord round the load drum and attach the hanger. You know, I already attached. This is the load drum. Okay, this one is the load drum. I already attached the hanger to this load drum. Okay, after that what we have to do, they said add the weight of 10 Newton to the hanger. Okay, so I am going to add 10 Newton to this hanger. Okay, I add 10 Newton. Okay, after adding 10 Newton, what we have to do, we have to wind the fin cord around the drum on the worm shaft and add the hanger and apply weights to the hanger. Okay, so this one also I add the fine cord to this shaft with hanger. Okay, so now what we are going to do is we are going to gradually add the weight on this side to see how much effort we need to just lift the load side of the weight. Okay, so I am going to start with what, 2 Newton. Okay, now you see the load side, how much total weight, 10 Newton plus the hanger 1 Newton, so 11 Newton. So I am going to add this 2 Newton first. Okay, I add, but it doesn't move it. Okay, so I am going to add another 2 Newton. Okay, I am going to add another 2 Newton. Still it's not moving, so I am going to add another 2 Newton. Yes, when you add the another 2 Newton, it's move. Okay, so the effort should be in between how much? You see, this one 2 Newton, 2 Newton, and this one 2, 6 and 7 Newton. But it should be between the 7 Newton and 5 Newton. So I am going to take out this 2 Newton because I want to find out the minimum effort to just move the load weight. Okay, 2 starts worm also I did, and single starts worm also I did. So now you note down the values. Okay, for a load 10 Newton, the effort 6, and for effort 20 Newton, for a load 20 Newton, effort 9.5. For load 30 Newton, effort 14.5. For effort 40 Newton, effort 19.5. Now 2 starts on the worm. Okay, for 2 starts on the worm, okay, load is 5.5 and 10.5 and 15.5 and 20.5, effort 2 Newton, and for a 10.5 3 Newton, for 15.5 4.5 Newton, for 20.5 6.5 Newton, 6.5 Newton, for 25.5 8 Newton, for 30.5 9.5 Newton. Okay. 9.5 meter. Specimen calculation. Before specimen calculation, you have to fill up first these tables. It's the same. Mechanical advantage. Mechanical advantage is equal to what? Load over effort. So you have to divide this load over effort. So you have to fill up this table. Okay, you have to fill up this table for the two table. No, now you have a two table for the observation sheet. One is for the one start on the worm. Another one is the two starts on the worm. Okay, then you have to fill up. So you can calculate mechanical advantage using this equation W over E, load over effort, right? So you can fill out this column. Then efficiency. Efficiency equal what? Mechanical advantage over velocity ratio. So velocity ratio, it's already, you have an equation, no? Ideal effort given by F over VR, right? So you know all load here and this into velocity ratio. You know the velocity ratio. Okay? You can derive the effort of friction also. You might see that. The same thing what you did for the rack and pinion and for bevel gears. Okay, so you have to fill up this table. There's a two table. You have to fill out those two tables. Okay, then results part. Go to the results. On the worm wheel is given 40, but number of the starts on the worm for a one set 1, for another set 2. So that's also given. Okay, 1 and 2. So now you go to the results part. Okay. Okay, then go to the results part. Okay, on the results section, how many graph you have to plot? 3. Okay, for each set, there's a one gear set and another gear set. For each set, you have to draw 3 graphs. Okay, one is load versus EA, actual effort, and load versus ideal effort. Okay, and load versus mechanical advantage. Okay, so you have to take the 2 graphs. Okay, you have to take the 2 graph sheet. Okay, okay, let's take I take this one. Okay, I take first graph sheet and draw. I don't know how it's coming. You have to draw 3 graph on one graph sheet. Then another graph sheet, you have to draw 3 graph. Okay, this one is the maybe this one is the load. This one is what? EA. Let's say this one is the EA. And this one is the EI. And this one is the MA. Now we move to the discussion session. What are the effects of 1 to 2 starts on the worm on velocity ratio and mechanical advantage and efficiency and the law of the machine? You have to describe, you have to discuss. Okay, when the starts different, what are the effects on the velocity ratio and mechanical advantage and efficiency and law of the machine. Second question, what is the limiting efficiency of each gear set? So the equation is given above on the lab sheet. If you look at the lab sheet, you see the efficiency on the under the theory section. Under the theory section, it's given. Limiting efficiency is given by 1 over A into VR. A is what? You can derive this A from the graph, right? On the graph, you know, you can find out this equation, you know, effort equal for A plus B, no? This equation, you can find out, no? The slope of the graph is A, right? The tan theta is equal to A, right? Okay. You have to draw this graph, EF versus F, in order to derive the law of machine. Because if you find out the law of the machine, then only you have to draw this graph also on the same graph sheet. Or you can draw in a different graph sheet. It's up to you. Okay, EF minus F, it should be like this. F is the X coordinate, EF is a Y coordinate. Better you draw in a different graph sheet. Okay, then you can draw the graph versus EF minus EF versus F. So this one, EF is given by EA minus EI, you know. So EA and EI, all you know from the table, right? EI is the ideal effort, is the actual effort. So this one, friction effort, okay? So EF equal to AF plus P. So if you draw this graph, then you can find out the slope of the graph is gives A, right? Value of A. And the intersection gives value of B. Let's say this is the graph, okay? The EF minus F, let's say this one is your graph, okay? So if this is your graph, then this point is what? B, right? Tan theta equal what? Tan theta equal A, right? The slope of gives the A, right? Okay, so you can find out A from this graph. So additionally, you have to draw this graph. Otherwise, you can't find A. EF, that's mean friction effort versus load. You have to draw this graph. Then only for the two graph you have to need, no, for gear set 1 and gear set 2. So if you draw these two graph, then you can find out the A. So if you find out the A, then you can put insert A and VR also. VR also, you know, each gear set. Then you can derive the efficiency, limiting efficiency for each gear set. This is your discussion second question, right? What is the limiting efficiency of each gear sets? So you have to draw that graph, the friction effort versus load, and find out the A and insert the A values into that equations. Then you can get the limiting efficiency of each gear sets.